Math Shorts.
Proportional relationships. Two quantities are said to be directly proportional if they vary at the same rate. Meet Carl. He's mixing punch for a party. The recipe calls for 2 cups of juice for every cup of ginger ale. If he doubles his recipe, meaning he multiplies it by 2 to start with 4 cups of juice, he'll need 2 cups of ginger ale to keep the ratio of juice to ginger ale 2-to-1. If he triples his recipe, he'll need 3 cups of ginger ale. All the ratios of juice to ginger ale are equivalent. They all simplify to 2-to-1. This means that the relationship between the 2 quantities of juice and ginger ale are directly proportional. Another way to see proportions is with a graph. We can plot 2 cups of juice and 1 cup of ginger ale like this. We can show how Carl doubles and triples the original recipe like this. A straight line through the data points shows a direct proportional relationship as long as the line goes through the origin. But what happens when the line doesn't begin at the origin? Check out this graph. The line starts at 3 cups of ginger ale, so we would need to add 3 to all our previous answers on the table. But if we do that, the ratio of juice to ginger ale is no longer constant. The 2 quantities don't increase at the same rate. This is not direct proportionality, and Carl's punch won't taste so great. Ratios, tables, and graphs can help us identify proportional relationships and make awesome punch.
You heard it. Directly proportional relationship is when you have 2 quantities that vary at the same rate. We can see it on a graph, we can see it in a table, and that's what we're going to practice. Looking at our table, we have nachos sold, money collected. Look at the x-axis with the graph and the y-axis. Label them in your notes. We're going to start by taking the information from the table and putting it on the graph. So our first ordered pair is going to be 0, 0. When x is 0, y is 0. Our second ordered pair is going to be 1, 3. So when x is 1, y is 3. Our third ordered pair is going to be when x is 2, y is 6. The next one, when x is 3, y is 9. And the last one, when x is 4, y is 12. That's going to be off my graph, so I'm just going to choose not to graph it right now. I got 4 points, that's enough. These 4 points are falling very nicely in a linear pattern, so I'm going to connect them. Aha! Right away I can tell this is a directly proportional relationship. Here's the reason why. First, it's a straight line, but this is the big thing. Fill this in on the left-hand side with me. It's going through 0, 0. This line is going perfectly through the origin. Because of that, it's directly proportional. So it's a straight line right through 0, 0. I just got to look at the picture. I could have a straight line, but it could be going through a different part on the coordinate plane. And that would make it not proportional. So it has to go right through the origin. I can also determine if 2 quantities are varying at the same rate by looking at a table. So going back to our table, focus on the $3 per nacho. I'm going to write that in on the left-hand side here. That's our unit rate. That means every time we sell a nacho, we're making $3. We should be able to take every y value in our table, divide it by its x value, and get 3. Get our unit rate. So I'm going to do that. I'm going to take the y value and divide by x. 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. 12 divided by 4 is 3. Do you see how I have 2 quantities that I'm relating, y and x, and that relationship is remaining constant throughout my table here? Therefore, this is a directly proportional relationship. Maybe you didn't see it that way, but maybe you saw it how, well, Mrs. Kluver, I can see 1 times 3 is 3. I can see 2 times 3 is 6. I can see 3 times 3 is 9. Do you see how that 3 is constant again? That information is telling us that our quantities in this table are varying at a constant rate. We can also see that through our slope. Starting with our lowest point, which is the origin, we would go up 3, right? That's our change in y. Look at our ratio. It starts with y over here, and we go over 1. That's our change in x. And that slope gives us a 3-to-1, which is that constant rate of change that we're seeing in that table. Just from being able to identify that my values are changing at a constant rate within the table there by either going y divided by x or seeing what I'm taking times x to get y, I'm able to go, this is a directly proportional relationship. Lastly, look at this. Focus on the nachos sold. As the number of nachos sold increases, it's going from 0 to 4, right? What happens to the amount of money collected? The amount of money also increases. It's 2 thumbs up. It's directly proportional. My x value, my y value are both going the same way. They're both increasing. Do you see how this is a directly proportional relationship now? We're looking for a graph that's going right through the origin with a straight line. We're using that unit rate to make sure that unit rate is constant as we move throughout our data. Let's look at another example. This is a directly proportional relationship, but let's see if we can remember how to tell given the graph and the table of values. Looking at our table, we have hours worked, money earned. Look at the x-axis, look at the y-axis, and pay attention to how they're numbered. I can see my x is labeled hours, my y is labeled money, and I also notice my y is going up by 8. Let's take the information from the table and graph it into this quadrant 1. Our first point is 432. So I'm going to start at my origin, go over 4 up to 32. The next point is 324. Over 3 up 24. Then we have 216. So over 2 up 16. We have 1 8. So we're going to go over 1 up 8 and 0 0. These points are falling in a linear pattern. I love it. We're going to connect them and voila, I noticed something right away. Not only is it a straight line, fill this in on the left-hand side, but it goes right through what? 0 0. So we know that it is a directly proportional relationship. Let's look at it in the table of values. Let's see if we can identify that unit rate. Sometimes it's visible, sometimes it's not. I can see it in my table. It's $8 for every hour's worked. I'm going to write that down. If it wasn't visible, remember, unit rate is where we're taking our y value and dividing it by x. I want to check to make sure that when I take every y value and divide it by its x value in this table, I'm getting the same value. That's telling me that I have a constant rate of change. So I'm going to test that out here. 32 is my y, divided by 4, which is my x. That gives me 8. 24 divided by 3, 8. 16 divided by 2, 8. 8 divided by 1, 8. 0 divided by 0, well, 0 is special in general. We're just going to let that one be right now. We know we can't divide by 0. So I can see that I have a constant rate of change here. It's 8. I can also see that looking from side to side. 4 times 8 is 32. 3 times 8 is 24. 2 times 8 is 16. I'm multiplying by the same value to get my y's. I can also see that within the graph looking at my slope. Starting with my lowest point here, right at the origin, I'm going to rise up. That has a value of 8, and I'm going to run over 1. 8 over 1 would be my slope, which I would simplify to be 8. Based off that information, this is a directly proportional relationship. Lastly, I want you to look at the number of hours. Notice how they're going down. As hours worked goes down, what happens to the money earned? The money earned goes down as well. It decreases. Notice how I have 2 thumbs down. My x and y values are going the same direction there. They're directly proportional. On the left-hand side, make sure you have everything filled in. Let's take a look at what a inversely proportional relationship would look like. It really doesn't look that different than what we've just done, but we need to see it on a graph and then look at those relationships within the table. Let's go ahead and let's plot the information from our table onto the graph, paying attention to what the x and y axes are labeled as and how they're numbered. I can see time traveled is my x value And how fast I'm going, my speed in miles per hour, is my y. I can also see that my y-axis is going up by 10. My first point is 160. So starting at the origin, I'm going to go over 1 up to 60. My second point is 230. So over 2 up to 30. Then I have over 3 up to 20. I have over 4 up to 15. I have to estimate where 15 is because I don't have a specific tick mark for it, but I know it's directly between 10 and 20, so I'm going to try and do my best there. 5 and 12, I'm going to have to estimate where 12 is as well for my y value. There we go. Now I can still see that these points are flowing in a certain pattern, but it's just not as straight as the other ones, right? It's more of a curved line. That's one way to tell that this is an inversely proportional relationship. I get a curved line. Fill that in. And does it go through the origin, 7th graders? No, not through 0, 0. So it's inversely proportional if it's a curved line and or if it doesn't go through 0, 0. Since this is a curved line, I don't have a slope. But is there a pattern? Do I have a unit rate? Well, I can see right here I have 60 miles per hour for every hour traveled. But is that constant as you move throughout the table of values? Well, let's check it. I know that 60 divided by 1 is 60. Remember, we take our y and divide it by x. So 30 divided by 2, is that 60? No, that's 15. 20 divided by 3, is that 60? No. I don't have that constant rate of change as I move throughout my table of values. So therefore, this is an inversely proportional relationship. There is a pattern though, however. Can you see it? Look from side to side. 1 times 60 is 60. 2 times 30 is 60. 3 times 20 is 60. 4 times 15 is 60. 5 times 12 is 60. So while this is inversely proportional, there still is a constant pattern. Our constant value that we're getting when we take our x and we multiply it to our y is 60. So inversely proportional relationships have an x times y pattern. We can also notice it, if you didn't fill that in on the left-hand side, make sure you do that. Look at the speed you drive. So that's your y values, okay? So as the speed you drive goes down or decreases, what happens to the time traveled? It goes up. We can see that our x and y's are not going the same way. This is an example of an inversely proportional relationship. It has a curved line. It's not going through the origin. There's no slope. The unit rate is not a consistent rate of change throughout the table of values. Let's go to the examples on the back of our notes. Can we tell if something is directly or inversely proportional? Well, we've just practiced deciphering between the two. Let's look at number 1. And we're going to use our thumbs here, okay? The lower the rain total at Lake Orono, the lower the lake's water level will be. Right now, my x and y values are both moving in the same direction. Would this be directly or inversely proportional? Flip back to the front of your notes. Where did we have 2 thumbs down? Directly. Look at number 2. The lower the cost of gasoline, the more trips people will take. Is this directly or indirectly proportional? We have a value down, a value up. Look back in your notes. Inversely proportional. Going to number 3, we actually have this table already in our notes. But can you determine by going y divided by x if there is a constant rate of change? 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. 12 divided by 4 is 3. There is a constant rate of change. The value is consistent. It is directly proportional. How about in the other table? Take your y divided by x. Are you getting the same value each time? 50 divided by 1 is 50. 25 divided by 2 is 12.5. Whoa, hold up. I'm not getting the same value. When we weren't getting the same value, we knew it's inversely proportional, but then we did still have a constant pattern. Do you remember what it was? X times y gives you that constant number. So 1 times 50, what is that? 50. 2 times 25, what is that? 50. 4 times 12 and a half, 50. 10 times 5 is 50. So yes, we still have a pattern, but it is not a constant rate of change. Therefore, it's inversely proportional. Now, focusing on graphs, remember it has to go through the origin in order to be directly proportional. Number 5, that goes right through the origin, directly proportional. Number 6, it's not a straight line and it doesn't go through the origin. It's what? Inversely proportional. Let's sum up this lesson, 7th graders. Go ahead and in your summary box, cut it into 2 boxes. In one box, talk about directly proportional relationships. In the other box, talk about inversely proportional relationships, the difference between them. Thanks for sticking with me through this lesson today. I hope that you are more confident than you were coming into it about directly proportional and inversely proportional. Make sure you get your summary down and have a beautiful rest of your day.